Hi folks, welcome back. So now it's time to go into the theoretical definitions and the different terminologies for machine learning, right? So before we actually go more deep dive into machine learning, what I thought was, won't it be better to actually give you guys a good understanding of different terminologies? It's very important because whenever you are reading about machine learning, artificial intelligence, or when you're talking to AI professionals, data scientists, these are the kind of words they will keep on saying. And if you don't have a good understanding of these words or terminologies, you'll really struggle in the field of machine learning or AI. So let's take a look what these are. Very fundamental concepts, right? The very first one is an algorithm, right? What is an algorithm? Now, if I ask you a general definition of algorithm, a general definition of algorithm when we used to study maths or even physics, what was algorithm? So algorithm is always refers to a set of rules. And in machine learning, an algorithm refers to a set of rules and statistical techniques, right? Now, you might remember, but what is statistics? So a clear definition of statistics is nothing but study and manipulation of data, including the ways to gather, review, analyze, and draw conclusions from data, right? So it's nothing but you have a lot of data, and from that data, you need to draw some conclusions, right? So that is the branch of mathematics, which is called statistics. So algorithm is a set of rules and statistical techniques. Now here we take a good example of this. There is a decision tree algorithm, right? Now a perfect example of that is Gmail, right? When Gmail came, So when Gmail came, it never had a concept of filters, right? After some time, they came up with the concept of filters where they used to put spam or not spam, right? What are they doing? They are looking at your data. They are looking at your emails, and based on certain set of rules, they are telling you that, oh, this email seems to be a spam email and this email seems to be a, say, not spam email. And how are they doing it? They're doing it based on the features, right? Now, in machine learning world, we call them features, right? Or you could even say artifacts, right? But it could be features like who is the email sender. Now, there could be certain blocked set of senders in the list of Gmail. If they look at it, if the person who's sending is out of that block list, they can easily tell. They can also tell about the frequency of certain words. It could be like, hey, you have won a lottery, or there is money in your account, right? So these are the kind of things which are luring you to actually click on certain links. They can easily make out that it's just spam or not spam, right? So this is your algorithm. Next comes the concept of a model, right? Again, model is what an algorithm creates. So always remember, a model is derived from an algorithm, right? So a model is derived from an algorithm. So a model is what an algorithm creates, right? After being trained on the data. We'll look at training as well, but for the moment, just try to understand that a model is coming from an algorithm, right? So it is essentially the learned representation of data. Another way to say a model is it's a learned representation of data. If I keep on feeding the data, then based on that, I can easily learn from that data, right? And then the program that can find the patterns to make the decisions. So think of it like a Python program, right? We will see in more details as well. So a model could be, you can say it's a Python program which can find the patterns for making decisions, right? Now, algorithm was a set of rules based on statistical techniques. Model is something which is derived from the algorithm, right? And here we give an example of a data set of house features, right? And the prices to a regression algorithm. The model it creates can predict price of new houses based on the feature. So let's say if I feed a lot of data, right? If I'm feeding that, okay, if the elevation of the house is this much and the features of the house is this much, what could be the price of the house, right? So if we feed that kind of data, if I feed new data, then based on my model, it can easily predict, hey, your house can fall in the range of say 100,000 to 200,000 or 200,000 to a million, right? So it goes like that. So model is an algorithm, is what an algorithm creates after being trained on the data. Please remember that. And it's a program that can help you find patterns to make decisions. Right, now comes the concept of training, right? So you always train your model. Remember, you are training your model, right? Like the way you are training your baby to make decisions or your child to make decisions, same way you're training your model. So this is the process of presenting the data to machine learning algorithm. So what are you doing in training? You are getting a lot of data and you're giving it to the machine learning algorithm to create a model, right? So you take the data, you train, and then you create a model. And then you create a model. So you take the data, you train the data, and then you create a model. So presenting data to a machine learning algorithm to create a model. Right, the algorithm uses training data to learn. So always remember, this algorithm depends on the training data to actually learn from it. And another example, good example of it is a neural network. So let's say if I show thousands of pictures of cats and dogs to the training model, it can help me identify which is a cat and which is a dog. Just based on the features, it can tell me if I just add, okay, the ears are like this, the eyes are like this, and if I give you a few more features, then the neural network would be able to tell me whether based on this, is it a cat or is it a dog? Very important. So training, you are training, which is the process of presenting the data to machine learning algorithm, which creates a model. Then there's a concept of labels. Again, label is nothing but this is the output you want the model to predict. Very simple. It's just a key terminology for machine learning. If somebody asks you what are the labels, labels is nothing but he or she is asking you about the output, right? What is the output? And here we take an example of a tumor. Say you want to see whether the label is, the label might be whether the tumor is malignant or benign. Malignant means whether the tumor is really dangerous, or benign means that it's fine. It's not a major issue, right? So just take an example from the healthcare. So yeah, I think with this we come to the end of machine learning key terminologies. Remember, algorithm, set of rules. Model is what an algorithm creates after being trained on the data. Training is a process of presenting a lot of data to machine learning algorithm to create a model, right? So you train the data and you create the model. Then labels are nothing but the output. So thanks for watching.